Good evening, ma'am.
Good
Good evening,
sir.
ma'am.
Good evening, sir. You can continue, sir.
Good evening to all. Good evening.
Good evening, sir.
Yeah. Good evening, Ajay. All right. Anybody else there in the class? There are a few. Others?
Good evening, sir.
Yes. Can you see the screen? Can you see the screen?
Yes, sir.
Okay, we'll continue. The new chapter, electrochemistry. It's a very lengthy chapter. All right, we have done only 2 chapters so far. We have so many more chapters to do. We will see how fast we can complete. The 3rd chapter is electrochemistry. This electro is related to electricity. And we know that this chemistry related to chemical reactions. Chemical reactions. Now, what is this electrochemistry? Now, electrochemistry is a branch in physical chemistry which deals with interconversions of energies. Interconversions of energy. It's a branch in physical chemistry which deals with interconversions of energies. What do you mean by interconversions of energies? Now, chemical energy can be converted into electrical energy. So, and likewise, electrical energy can be converted into chemical energy. Now, for an example, when we talk about a battery, whether it's a pencil battery or a car battery, okay, any other battery, if we are talking about the battery, in the battery, there are chemicals. Mobile phone battery also, if you talk about, they have a chemicals inside. Lithium, as in mobile phone battery, you have, it's also called as lithium ion battery, right? So chemical reaction takes place inside the battery or in the battery so that electricity is produced. So chemical energy is converted into electrical energy. A cell which converts chemical energy into electrical energy is called as electrochemical cell. It's called as what cell? Electrochemical cell. What is electrochemical cell? A cell which converts chemical energy into electrical energy is called as electrochemical cell. Okay, different types of cells we're going to learn in that particular topic. But for now, you understand when we talk about a battery, car battery, sulfuric acid is there, zinc electrodes are there. So chemical reactions will take place in the battery so that electrical energy is what produced. So a cell which converts chemical energy into electrical energy is called as electrochemical cell. Likewise, a cell which converts electrical energy into chemical energy. A cell which converts electrical energy into chemical energy will be called as electrolytic cell. It will be called as electrolytic cell. Electrolytic cell. So we can write as a branch of electrochemistry which converts chemical energy into electrical energy or electrical energy into chemical energy. Therefore, I defined electrochemistry as a branch in physical chemistry which deals with the study of interconversions of energies. All right, the actual definition you can see, electrochemistry is a branch in physical chemistry which deals with the relationship between electrical energy and what? Chemical energy. So what type of reaction takes place between electrical energy, the cells? What type of reaction takes place in these cells? The reaction which takes place in these cells will be called as a redox reaction. What do you mean by redox reaction? A reaction in which a reduction and oxidation takes place simultaneously is called as redox reaction. We will learn more in detail about redox reactions a little later. Now, for now, redox reaction means a reaction in which reduction and oxidation takes place simultaneously will be called as a redox reaction. All right. Now, we will learn the next, what happened here. There is that. All right, now we will learn something with respect to electrolytes and electrolysis. Now, this chapter, electrochemistry, deals with study of interconversions of energies in solution state. We are not talking about interconversion of energy in what solid state. We talk about the interconversion of energy in what solution state. In order to redox reaction in solution state, we need to understand certain terminologies. And the first terminology is electrolytes and a process called as electrolysis. Now, what is an electrolyte? Now, for an example, if you take sodium chloride in aqueous medium in water, the sodium chloride will dissociate to form Na plus and Cl minus. Na plus and Cl minus. Keep this in mind. Now, I will take a container, a beaker I will take, and I take water into this, and to this water, I will add little of sodium chloride. It becomes sodium chloride solution. I have two electrodes. One is a positive electrode, the other one is a negative electrode. We learn about electrodes all that little later. This is connected to a power supply. Now I switch on the battery and ask you to place your hand into this container. What will happen? What will happen if I ask you to place your hand into this solution? What will happen? What do you expect to happen? Please tell me what will happen. Can you hear me? Hello? Hello?
Sir,
Ajay? Can you hear me?
yes, sir, you're audible.
Yeah, please tell me, Ajay, what will happen if I put your hands? Tell me, Dhanalakshmi, what will happen?
Sir, once again, question, sir.
In a beaker, I have taken water. To this, I have added sodium chloride solution. I have placed two electrodes, anode and cathode, positive electrode, negative electrode, which is connected to a power supply, battery, or a direct power supply. Now, I switch on the battery or the power supply and ask you to place your hand inside the solution. What will happen?
Sir, we get a shock, sir.
Why will you get a shock?
So, because electricity will be passing through it, sir.
How? What is the carrying electricity?
Sir, Na plus and Cl
Very good.
minus.
Very good. Now, NaCl will dissociate to form Na plus and Cl minus. The Cl minus ions will move towards what? Positive electrode, and Na plus will move towards what? Negative electrode. The movement of ions will help to carry the electricity. Therefore, what happens is if anybody places a hand into it, it will there will be electric shock. This is first illustration. The second illustration, the same experiment we will perform. Now, same experiment we'll perform. We will take benzene into it. We'll take benzene into it. Two electrodes I place, positive electrode and negative electrode, connected to a power supply. I switch on the battery, power supply, and ask you to place your hand into it. What will happen? What will happen? Take a guess. What will happen? Will you get a shock or not? And if you get a shock, why? And if you don't,
No,
yeah,
sir.
tell me. You will not get a shock. Here you will not get shock. So therefore, no shock. Why there is no shock here?
So, because it will not dissociate
not-
into ions, sir.
Correct. There is no dissociation. That means there is no ions formed here. Therefore, there is nothing to carry what? Electricity. Therefore, this benzene will be a non-conductor of electricity. Now, these two examples you understood. Now we will define what is an electrolyte and electrolysis. Generally, these electrolytes are ionic compounds. Ionic compounds, or this is also called as electrovalent compounds. Electrovalent compounds. So what is electrolyte? a chemical substance in which dissociates in aqueous medium is called as an electrolyte. Now, see the proper definition of electrolyte. The substance which conducts electricity in solution state, molten state, or in fused state is called as an electrolyte. What do you mean by electrolyte? A chemical substance which conduct electricity in solution state, fused state, or in molten state is called as an electrolyte. What is an electrolyte? Any chemical substance which conducts electricity in solution state, fused state, or molten state is called as what? An electrolyte. Now, solution state means you know what is solution state. When a salt is put in water, it becomes a solution. Example, I gave you water in NaCl. Now, what do you mean by this fused state or molten state? If you take NaCl solid and if you heat it to very high temperature, it becomes a semi-molten or it becomes a semi-liquid state. It becomes a semi-liquid state. This semi-liquid state is called as fused state, or it is called as what state? Molten state. Did you understand what is fused state or molten state?
Yes, sir.
Yes. Now, you should remember this question. All right, it's an important question. Please try to understand this question. All right, the third illustration is this. You people have to answer me. In a beaker, I take NaCl. I take what? NaCl. I immerse two electrodes. Positive and negative, and connect it to power supply. Switch on the battery, and I ask you to place your hand inside. What will happen? What will happen? What will happen? Huh?
So shock.
Tell me, others. Tell me. Tell me what will happen. Will I get a shock or not?
So yes, sir.
Why will I get a shock? Now, I told you, I take a beaker. In that beaker, I place NaCl and two electrodes are placed connected to a power supply. Power's on, and I'm asking you to place your hand into it. Tell me, why will I get a shock? When I say NaCl, what is that NaCl physical state? It's a solid.
Yes,
In
sir.
solid, do we have possibility for these ions to move towards the respective electrodes? Not possible. Here in solid state, the ions are not free to move. Therefore, solid substances like NaCl, KCl, or any other salt will not conduct electricity. It's an important one mark question for 11th and 12th exam. All right. So why solid ionic substance does not conduct electricity? Solid ionic substance will not conduct electricity because ions are not free to move. See, the same thing in here, I clearly mentioned water and NaCl is the solution. In solution, current will be conducted because ions are free to move here. All right. Here, ions are not free to move. Ions are intact. In sodium chloride, Na plus is there, Cl minus is there, but it's as a compound. It's as a salt, solid. Therefore, ions are not free to move. Now, what is the definition of an electrolyte? An electrolyte is defined as a chemical substance which conducts electricity in solution state, fused state, or in molten state is called as what? An electrolyte. See the definition here. It's a lengthy definition. A substance whose aqueous solutions undergo decomposition into ions when electricity is passed through them is known as electrolyte. And the whole process is known as electrolysis. Now, we have to understand this. NaCl, when you put in water, it will dissociate to form Na plus Cl minus. Not necessary for to pass current, but if you pass current, this dissociation pattern will be much faster, maybe. All right. So, but here the definition says the substance whose aqueous solution undergoes decomposition into ions when electricity is passed through them is known as an electrolyte. And this process, decomposition of an electrolyte by passing electricity, is called as electrolysis, or it is also called as what? Electrolytic decomposition. Did you understand what is electrolyte now? What is electrolyte? Chemical substances which conducts electricity in solution state, fused state, or in molten state is called as an electrolyte. Or what is the definition as per the material? It says the substance whose aqueous solution undergoes decomposition. Sodium chloride in water is called as what? Aqueous solution of sodium chloride. So aqua means water. A substance whose aqueous solution undergoes decomposition into ions when electric current is passed through them is known as electrolyte, and the whole process is known as electrolysis. And or it's also called as electrolytic decomposition. Now, example for an electrolyte. Now, we have before, okay, example for an electrolyte, all acids are example for electrolyte. When we say all acids, HCl, H2SO4, HNO3, nitric acid, okay, H2C2O4. What is H2C2O4? Anybody? H2C2O4? What is H3PO4? H3PO4.
Phosphorus
So
acid.
phosphoric acid.
What is H2C2O4? H2C2O4 is oxalic acid. Oxalic acid. What is H2C2CO3? It's called as carbonic acid. Carbonic acid is nothing but soda water. Carbon dioxide dissolved in water will be called as what? Carbonic acid. So all the acids are example for an electrolyte. Not only all the acids, likewise, all the bases are example for electrolyte. When we say all the bases, potassium hydroxide, sodium hydroxide, ammonium hydroxide, calcium hydroxide, etc. These all are the examples for what? An electrolyte, all the bases. Not only all the bases, all right, we will have all the salts also as an example for electrolytes. All the salt. How salts are formed? How salts are formed? How salts are formed?
So acid plus water.
Acid-based reaction gives you what? Salt and water. It's called as neutralization reaction. NaCl, KCl, K2SO4, Na2SO4. It goes on. So any salt, acid, any acid and base will react to form what? Salt and water. All the salts are example for an electrolyte. Now, what's an electrolyte? Chemical substance which conducts electricity in solution state, fused state, or in molten state is called as an electrolyte. Or decomposition of an electrolyte by passing current will be called as electrolysis. All right, it's otherwise called as what? Electrolytic decomposition. Now, we have learned the examples for electrolytes. What are the examples we have learned for electrolytes? All the acids, any acid, all the bases, and also all the salts are example for electrolytes. Now see, solutions of acids, bases, salts, and water, and fused state, etc. are the examples for electrolytes. But here you should understand, electrolytes may be strong or what? Weak. So there are electrolytes is further classified into two. When I say electrolyte is further classified into two, one is called as a strong electrolyte, the other one is called as what? A weak electrolyte. What do you mean by a strong electrolyte and weak electrolyte? We have to understand. They can ask you the difference between strong electrolyte and weak electrolyte. The first one is strong electrolyte. These are electrolytes which undergoes complete dissociation. Even at dilution is called as a strong electrolyte. What do you mean by a strong electrolyte? An electrolyte which undergoes complete dissociation, even at minimum dilution. That means even though you take little amount of water, the electrolyte will undergo complete dissociation. That means it will undergo complete ionization. It will break into what? Ions completely. Those are called as strong electrolytes. Now, what is the example for strong electrolyte? All strong acids. All strong acids. When we say all strong acids, only three acids we know, that is H2SO4, HCl, and HNO3. Hydrochloric acid, sulfuric acid, and nitric acid. These are the three strong acids. All the other acids are what? Weak acids. So all strong acids are example for strong electrolyte, because this HCl will undergo complete dissociation. Now this HCl will undergo complete dissociation to form H plus and what? Cl minus. Likewise, H2SO4 also will dissociate to form 2H plus and SO4 2 minus. Likewise, nitric acid also will undergo dissociation to form H plus and NO3 minus. So even though you take little amount of water, the dissociation of these acids are complete. Therefore, these kind of acids are called as strong acids. So strong acids are examples for strong electrolyte. Likewise, all strong bases. When we say all strong bases, only two strong bases we know, that is potassium hydroxide and sodium hydroxide. This potassium hydroxide also will undergo complete dissociation to form K plus and OH minus. Likewise, NaOH will dissociate to form Na plus and OH minus. So the strong bases which undergoes complete dissociation will be called as an example for strong electrolytes. Likewise, all the salts, any salt for that matter, is an example for strong electrolyte. Did you understand what a strong electrolyte? Can you understand the examples for strong electrolyte, students?
Yes, sir.
Yes. Now, weak electrolyte we have. Now, what is this weak electrolyte? It's the opposite of this. What's the opposite of this? Strong electrolyte undergoes what? Complete dissociation. Even at what dilution? Minimum dilution. That means weak electrolyte will what? Opposite of this. What will be the opposite of this? Weak electrolyte. What's the opposite of this? Electrolytes which undergoes partial dissociation. Even at maximum dilution. Even at what dilution? Maximum dilution. Even though you take lots of solvent, the electrolyte will undergo what? Partial dissociation. Very few molecules will dissociate to give few ions. Therefore, those kind of electrolytes are called as what electrolytes? Weak electrolytes. When we say weak electrolytes, example for weak electrolytes, all weak acids. All weak acids. Now, when we say all weak acids, excepting HCl, H2SO4 and HNO3, all the other acids are example for what acids? Weak acids, weak electrolytes. Likewise, all weak bases. All weak bases. When we say all weak bases, excepting NaOH and KOH, all the other bases will be example for what? Weak electrolyte. Did you follow this? Students, did you follow?
Yes, sir.
Others are there?
Yes, sir.
Yes. Now we will erase this. We have learned what is an electrolyte. We learned what is strong electrolyte and weak electrolyte. Now we have to define one more term that is called as a non-electrolyte. What do you mean by a non-electrolyte? I gave you an example for non-electrolyte in the beginning of the class. So non-electrolyte means generally the non-electrolytes are covalent molecules. Covalent molecules. So electrolytes are ionic, I told you, or electrovalent, I told you. So non-electrolyte, when we say it is a covalent molecule. What do you mean by non-electrolyte? If I put benzene in water, what happens? Firstly, benzene will not dissolve in water because benzene is a covalent compound, water is a polar compound. So therefore, they will not dissolve. Now, if you take pure benzene also, you told me the answer, benzene will not undergo ionization. Ions will not be formed. When ions will not be formed, it will not conduct electricity. I gave you the illustration. Okay, benzene I take in a beaker. I have two electrodes connected to the power supply. Switching on the power. If I ask you to place your hands into it, what will happen? You told me there is no current. No current conduction. Why? Because benzene is not undergoing ionization to form what? Ions. Therefore, benzene will be an example for non-electrolyte. What do you mean by a non-electrolyte? Now, chemical substance which do not conduct electricity in solution state, fused state, or in molten state will be called as a non-electrolyte. So here examples of for non-electrolyte: cane sugar, glycerin, alcohols, chloroform, carbon tetrachloride, urea. All these are examples for non-electrolyte. Only three examples they have mentioned: cane sugar, that is C6H12O6, right? Glycerin, alcohol, we can write carbon tetrachloride, chloroform, CCl4. We can write benzene, all right? We can write urea. All these molecules will not give ions in aqueous medium. Therefore, they are called as non-electrolytes. Did you understand this so far?
Yes, sir.
Yes, sir.
Yeah. Now, electrolytic cell, or it's also called as voltameter. What is this electrolytic cell or voltameter? The device in which the process of electrolysis or electrolytic decomposition is carried out is known as electrolytic cell. What do you mean by electrolytic cell? A cell or a device in which the process of electrolysis takes place or electrolytic decomposition takes place is called as electrolytic cell, or it is also called as voltameter. It's also called as voltameter. All right. Now we learned this. A voltameter converts electrical energy into chemical energy. A voltameter converts chemical and electrical energy into chemical energy. It is a wrong statement. It's a wrong statement. It is chemical energy into electrical energy. It's electrochemical cell. Oh, this is electrolytic cell. Sorry, this is right. Electrolytic cell. It is not electrochemical cell. Sorry, electrolytic cell. It's right. A cell which converts electrical energy into what's the chemical energy is called as electrolytic cell. I think I have written here. See, yeah. Electrical energy into chemical energy is called as electrolytic cell. Chemical energy into electrical energy is called as electrochemical cell. I have written here. That's right. So voltameter is a cell with which electrical energy is converted into chemical energy. The electrode on which oxidation takes place is called as anode, or the positive pole. And the electrode on which the reduction takes place is called as cathode, or a negative pole. So in electrolytic cell, I am specifying in electrolytic cell, anode is positive electrode represented by positive pole. Cathode is a negative electrode represented by negative pole. At anode, oxidation takes place, and at cathode, reduction takes place. So you should remember an-ox, and red cat. There's no red cat. I've not seen a red cat. But anyways, for now, you understand this. An-ox. You know what's NOx? An-ox means oxidation takes place at anode. Red cat means reduction takes place at cathode. That's what is the understanding. So oxidation takes place at anode and reduction takes place at cathode. Now, when we say oxidation and reduction, what do you understand by the term oxidation and reduction? Oxidation and reduction. Firstly, we will try to understand the term called as oxidation. Oxidation takes place at what? Anode. What do you mean by oxidation? Loss of electrons is called as oxidation. Or gain of, no, not gain, increase in charge is called as oxidation. Increase in charge is called as oxidation. What do you mean by oxidation? Loss of electron or increase in charge. Now, when we say sodium, when I take an example, simple example, sodium. What's the atomic number of sodium? What is the atomic number of sodium?
So 23.
23 is the atomic mass. Atomic number of sodium.
Sorry, 11.
Atomic number of sodium. 11. Atomic number of sodium is 11. Now, when we say atomic number of sodium is 11, right? The electronic configuration of 11 is 1s2, 2s2, and 2p, 6 and 3s1. This is the electronic configuration of water. Sodium. Now tell me, the outermost orbital, how many electrons are there? Which is the outermost orbit here? Which is the outermost orbit here? Which is the outermost orbit? 3 is the outermost orbit. You have first orbit, second orbit, and what? Third orbit. All right. In the third orbit, how many electrons you have?
So 1.
1. Is it stable? When an element is said to be stable? When it has 8 electrons. When it has what? 8 electrons. Great. Since it has only 1 electron, this will be what? Unstable. When I say this is unstable, what happened? This electron is lost. When this electron is lost, sodium will gain 1 positive charge. Because we know when I say sodium atomic number is 11, it means it has 11 electrons and 11 protons. In order to attain stability, if it loses 1 electron, here you will have what? 10 electrons and you'll have what? 11 protons. So 1 proton is more, therefore sodium will have what? Positive charge. So whenever there is a loss of electron, there is an increase in charge. Here the charge on sodium is 0. Here the charge on sodium is what? +1. So increase in charge is due to the loss of electron. Therefore, anode can be defined as loss of electron or increase in oxidation number is called as oxidation. So oxidation takes place at which electrode? Anode. So therefore we have to remember it as an ox. You have to remember it as an ox. Now similarly, when we take reduction, this reduction is I call it as red cat to understand. Reduction means gain of electron. Gain of electron or decrease in charge or decrease in oxidation number. Better to use the word oxidation number rather than charge. So decrease in oxidation number. Now for an example, in chlorine, what's the atomic number of chlorine? The atomic number of chlorine is 17. So atomic number of chlorine is 17. When atomic number of chlorine is 17, the electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, and 3p5. In the outermost orbit, it has how many electrons? 7 electrons. In order to gain stability, it will gain one more electron. When it gains an electron, what happens? Chlorine will have what? 1 minus charge. It will have 17 proton and it will have what? 18 electron. Since 1 electron is more, chlorine will gain what? Negative charge. Here the chlorine charge is 0. Here the chlorine has what? Minus 1 charge. Whenever there is a decrease in charge, it is called as reduction. So reduction is defined. Reduction happens at what? Cathode. Remember, reduction happens at cathode. Gain of electron is called as reduction. All right, or decrease in oxidation number is called as reduction. I gave you the illustration. Did you understand this? Oxidation and reduction.
Yes, sir.
Oxidation and reduction, you understood or not?
Yes, sir. Understood, sir.
Understood, sir.
Yes. Now, if I write a question, if I write a reaction like this, you should tell me what type of reaction is this. It is wrong what I'm writing, but let us see. This is not wrong. Let's see what will happen. Now I take Na and this sodium gives you 1 electron and gains positive charge. This electron of sodium is gained by the chlorine and gains negative charge. See, if something should be ready to accept electron, only then sodium can give electron. Just like that can give electron, what does it mean? Sodium is highly reactive, no doubt. But neutral sodium will not be there. If some other element should be in a position to receive electron. Now the electron is received by this chlorine. Therefore, chlorine gains what charge? Negative charge. Therefore, what happens? This reaction is called as a redox reaction. This is called as what reaction? Redox reaction. What do you mean by redox? A redox reaction means a reaction in which both reduction and oxidation takes place simultaneously is called as redox reaction. A reaction in which both reduction and oxidation takes place is called as redox reaction. See, this is oxidation and this is reduction. So loss of electron and gain of electron is taking place simultaneously. Therefore, what happens? This reaction is called as a redox reaction. Now, you should know what is a redox reaction. The definition of redox reaction is a chemical reaction in which both oxidation and reduction takes place simultaneously is called as a redox reaction. Now, we will learn this anode oxidation, cathode reduction. So that means, see, from sodium, the electron is moving towards chlorine. That means electron move from anode to cathode. The electrons flow from anode to cathode, and from cathode to anode, the current flows. The loss of electron and gain of electron at anode and cathode appears like what? Current. So current flows from cathode to anode. Did you understand what is oxidation reduction? Oxidation. I mean, did you follow what is oxidation reduction?
Yes, sir.
Yeah. Now, oxidation means what? What do you mean by oxidation?
So
What
loss
do you mean
of
by
electron.
oxidation?
Sir,
Loss of electron is called as oxidation.
loss of
Gain of electron is called as what?
Reduction.
Reduction. Okay. And at anode, what takes place? At anode,
Oxidation, sir.
oxidation. And At cathode, it is what?
Reduction.
Reduction. All right. All right. Next. See, here it's been mentioned. At anode, it's what? Oxidation. The oxidation means loss of electron. See, A minus, losing an electron, is also called as what? Oxidation. All right. Now, cathode is what? Reduction. Gain of electron is called as reduction. I taught you all this. This overall change is known as primary change, and the product formed is known as primary products. The overall change is known as primary change, and the product is formed is called as what? The primary products. The primary products may be collected as such, or they may undergo further change to form molecules or compound. These are called as secondary products. We will learn what is primary product, secondary product when we learn the chemical reaction. All right. Now, maybe I will explain it now itself otherwise. Now, if you take sodium will get deposited as Na plus will get deposited as Na. But if chlorine is formed, this chlorine cannot get eliminated as chlorine as Cl. It will combine with another chlorine and get eliminated as what? Chlorine gas. So this is a secondary product. Yeah, the sodium is a primary product. Are you following what I'm trying to tell?
Yes, sir.
You understood this? Okay. Now, preferential discharge theory. Preferential discharge. This is not there for your 12th standard, but anyways, we will learn. According to this theory, if more than one type of ion is attracted towards a particular electrode, then the ion is discharged, one which require less energy, or ions with low discharge potential, or which occurs low in the electrochemical series. Electrochemical series we have to learn in the last part of the topic. Now, what is this discharge potential? Now, for an example, if I take a solution of zinc sulfate, we have two electrodes here, positive electrode and what? Negative electrode. Now, the zinc sulfate will dissociate to form Zn2 plus and SO4 2 minus. Since it is a solution, water also will dissociate to form H plus and OH minus. Dissociates to form what? H plus and OH minus. Now, what's happening at anode? At cathode, what happens? Zinc is formed. Zinc undergoes reduction. Zn2 plus will gain 2 electrons to give what? Zn. Zinc will undergo reduction. But at cathode, at anode, what it's moving? Sulfate ion is moving and what? OH minus ion. Two ions are moving. Sulfate ions and what? OH minus ions are moving. Now, when sulfate ions and OH minus ions are moving, which will get dissociated, which will get liberated, which will get the product? So here it depends on something called as discharge potential, or which occurs low in the electrochemical series. This electrochemical series I told you I'll be learned later. So what happens is this OH minus will decompose to give oxygen gas. So oxygen gas will be liberated here at anode instead of what? Sulfate ions. There, that's called as what? Preferential discharge theory. According to this theory, if more than one type of ion is attracted towards a particular electrode, then the ion is discharged, one which requires least energy, or with a low discharge potential, or which occur in the lowest of the electrochemical series. The potential at which the ion is discharged or deposited on the appropriate electrode is termed as discharge or deposition potential. The potential at which the ion is discharged, liberated, or deposited at an electrode potential electrode is termed as discharge or deposition potential. The value of discharge potential are different for different ions. So deposition potential or discharge potential for different ions are what? Different. All right, because different elements have different properties, therefore they have what? Different discharge potential. The decrease in order of discharge potential, the decrease in order of discharge potential of the increasing or the increasing order of their deposition of some ions are given below. So cations, lithium will get liberated more easily compared to potassium, calcium, sodium, all this. For anions, sulfate, in nitrate, OH minus, Cl minus, Br minus, etc. It goes on. This we will learn in electrochemical series in detail. Now, we will solve few of the questions what we have learned from this topic. Now, before we learn from this topic, I have to give an illustration. Now, what's that illustration? All right, don't know. After this question, we will solve the illustration. Now, I hope that you understood with oxidation and reduction all that. Now, an electron is from, the flow of electron is from cathode to anode in the solution, or cathode to anode through external supply, from cathode to anode through internal supply, or from anode to cathode to through internal supply. What's the answer? In the electrolytic cell, the current flows from, no, not the current, electrons flow from anode to cathode through internal supply. So therefore, the answer for this question is option D. From anode to cathode through what? Internal supply. We will learn this internal supply, all that, when we learn a cell called as Daniel cell. Daniel cell. All right, the next question. The next question. Where is that gone? All right, this is the only question in the first part of the topic, I think. All right, so I have not given more number of questions. All right, so next topic we will learn products of what? Electrolysis. Products of electrolysis. This is important. This question is really important. This chart, tabular column, you should know. All right. Now, product of electrolysis. Name of the compound: sodium chloride. Sodium chloride formula is NaCl. State molten. What's the anion? Cl minus. What's the cation? Na plus. What's the product at anode? Chlorine is the product at anode. Sodium is at cathode. I told you sodium cathode reduction will take place. Na plus will gain one electron and get reduced as what? Sodium. Now, I'll take an example and then we will try to understand this quickly. Now, I explained this, but anyways, one more time we will learn. Right? I have sodium chloride solution. I have sodium chloride solution. And we have two electrodes connected to the power supply here. Connected to the power supply. Now, sodium chloride will dissociate to form Na plus and Cl minus. So you'll have what? Na plus ion and what? Cl minus ion. Na plus and Cl minus ion. This is anode and this is cathode. Na plus will move towards cathode. Cl minus will move towards anode. So at anode, what happens? At anode, what's moving? Cl minus is moving. Now, when Cl minus is moving, at anode, what should take place? Oxidation should take place. What do you mean by oxidation? Loss of electron. The Cl minus gives an electron and it becomes Cl. So here the charge is -1. Here the charge is 0. From -1 to 0, there is an increase in charge. Therefore, it is called as oxidation. So this electron which is given at anode, what happens is it will move, the electron will move through the external circuit. So electrons will move through the external circuit and gets towards cathode. Now, Na plus, this Na plus will accept this electron given by chlorine and gets reduced to sodium. So what happens is sodium metal will get deposited here at cathode and chlorine will get eliminated as a gas. So when I say chlorine will get eliminated as a gas, these chlorine atoms will combine with each other to form a chlorine molecule and it gets eliminated as a gas at what? Anode. So this is the basic electrolysis process. You should remember, metals will get deposited, non-metals will get liberated. So metals will get deposited at cathode, non-metals will get liberated at anode. Remember, so this is with respect to sodium chloride. So sodium as chlorine has what charge? Negative charge. Sodium has positive charge. So sodium will undergo reduction at cathode and get deposited as sodium metal at cathode. And chlorine, as I explained, chloride ions will undergo loss of electrons and forms chlorine gas and gets liberated at anode. So these cell reactions are called as half cell reaction. So the reaction takes place at anode called as half cell reaction of anode. The reaction taking place at cathode is called as half cell reaction of cathode. The same reaction here also happens. Just observe here. This is different. This is sodium chloride molten state. Here it is sodium chloride aqueous. Water is there. When water is there, again, it will dissociate to form Na plus and Cl minus. At anode, you'll get chlorine. And at cathode, sodium metal will get deposited at cathode, no doubt. But in water, we have H plus ions also. All right, deposition potential, discharge potential, we were learning. So in aqueous medium, H plus ions are there. This H plus ions will get reduced to liberate what gas? Hydrogen gas at cathode. Do you understand what I'm telling? Even though sodium ions are there, what is getting liberated? Hydrogen gas is liberated. Similarly, other example, cuprous chloride, cupric chloride. It's a molten cupric chloride. So chlorine gas at anode, chloride ion at anode, copper ion at what? Cathode. So the product at anode is what? Chlorine gets liberated at anode, copper gets deposited at cathode. But if you take aqueous copper sulfate solution, sulfate and copper 2 plus ions. So whenever sulfate salt is there, remember the product liberated at anode is what? Oxygen gas. See, in H plus, H2O, water, we have H plus and OH minus. This OH minus ions will move towards anode. At anode, this OH minus ion loses electrons to form oxygen gas. So oxygen gas will be liberated. It's an important question. This chart is important for 1 mark, any competitive exam. They'll ask you. And the metal liberated is what? Copper. When it is aqueous medium, it's very important. It is molten state, it's easy to predict the product. But in aqueous medium, the product has to be carefully predicted. Whenever you have sulfate, the gas liberated will be oxygen, remember, at anode. Similarly, for aluminum chloride, AlCl3, in molten state, chlorine will be at anode, aluminum at cathode. Metal will get deposited. Metals will get deposited. Non-metals will get liberated, remember. So if I take a lead bromide, molten state, all right, bromine gas at what? Anode, and lead will get deposited at what? Cathode. Because you are able to understand what I'm telling. Now, if we take lead bromide, it will dissociate to form Pb2 plus and 2 Br minus. So this Pb2 plus will move towards cathode, Br will move towards anode. At anode, oxidation will take place. At cathode, what? Reduction will take place. The simple reaction only is written here. All right. Similarly, potassium nitrate, if you take nitrate ion at anode and potassium. So if you take again nitrate, the gas liberated at anode is oxygen. Whether you take sulfate or nitrate, the gas liberated is oxygen. And here you have K plus as well as what? H plus, because aqueous solution, water is there. So whenever you take aqueous solution, the gas liberated at cathode is hydrogen gas. Hydrogen gas. Similarly with calcium bromide, calcium at what? Cathode, and bromine gas at anode. If you take aqueous zinc sulfate, see what's happening? Oxygen and hydrogen. Even though zinc is there, hydrogen gas will liberated at anode and oxygen gas at cathode. Same as this example, what we learned, sodium chloride. So silver nitrate, if we take silver nitrate aqueous, oxygens at anode and silver metal deposits at what? Cathode. And stannic chloride, tin chloride, stannic chloride, if you take chlorine gas at anode and tin gets reduced at cathode. So this tabular column or this chart, this video, you can just concentrate. This is an important question. You should know how to predict the products formed at anode and cathode during electrolysis. Any clarification so far? Any clarification?
No, sir.
No. All right, we'll continue with the next part of the topic in the next class. All right, we'll solve some questions and then we will learn in detail with the next topic. Now, the introduction to the electrochemistry, non-electrolyte electrolysis, products of electrolysis, we have learned what is anode, cathode, what is redox reaction, we learned so many things we learned today. So we'll continue the topic in the next class later. All right, thank you. Madam?
Yes, sir.
Yes.
Thank
Yes,
you, sir. Thank you, sir.
Yeah. Yeah.
Thank you, sir.